so that we can go through it to see what was the correct response that I expected in that paper. So let me share the screen. Let me share the screen so that I can navigate where the paper is. Share the screen. It is there. Good. So this was the week 2 exam for Digital Advantage Learning Management 2025, the Form 4 of April. So the first question wanted a learner to define what is a radian measure, of which we had already defined it. That, in fact, before I answer it, kindly, Serena, define for us what is a radian measure. What is a radian measure, Serena?
A radian is an angle subtended at the center of the circle whose radius is equal to the arc length.
Very good, very good, very good. A radian is an angle subtended at the center of an arc, of a center of a sector, whose radius is equal to the arc length, like that. So that is a simple definition of a radian measure. The angle subtended at the center of a sector or a circle whose radius is equal to the arc length. So even if we use a circle and we realize that the length of that circle, the length of the circumference, because for the circle, now it will be the circumference. The length of that circle or the circumference of that circle is equal to the length of that radius. Then that is automatically a radian measure. And for the circle, it will be 2 pi radian, because the angle at the center of a circle is 360 degrees. But now, if we just want to define it well, we just say that a radian is an angle subtended at the center of a sector whose radius is equal to the arc length. A radian is an angle subtended at the center of a sector whose radius is equal to the arc length. Because remember that a sector is a region bounded by 2 radii with an arc. A region bounded by 2 radii and an arc. And remember that an angle is formed by intersection of 2 lines. The region that arc swept in between intersection of 2 lines, that's referred to as our radian. Then from there, we went ahead and test on this mathematical calculation. A wheel makes 40 revolutions per minute, meaning that for minutes, it is making 40 revolutions. What is angular velocity? So when they compare that revolution with the time, automatically that is what's called the frequency, the number of revolution for 1 second, the number of revolution, the number of cycles for 1 second is referred to as frequency. Remember that when we have the frequency, we can get the angular velocity, and we define the angular velocity as the rate of change of angular displacement. So there, I wanted student to get what is called the frequency from this revolution. So our frequency there, which is denoted by letter F, it will be clearly as 40 per minutes. 40 revolution per minute. Revolution per minute. But for frequency, it should be per second. So this means that our frequency will be equal to 40. That per is the same as when I use the division as revolution, then per inakuwa divided by per minute is the same as 1 minute, like that. Then from this, since it should be per second, then clearly this one can be written as this. Can be written as, instead of minutes, now we convert these minutes into second as 60 seconds. In physics, you should be very keen with the SI unit. Don't write there sec. Sec is not the SI unit of second. Better you write there S. So this is 40. And then here we have a dot product. I can just put there the product. A dot product like this one. Here we have there a multiplication of revolution per minute. Or you can just put here 40 revolution like this. Then per is the same as reciprocal, equal 1 over 1 minute. This one should be 1 over. This one is a revolution. And then this one is a 1. So this one, when I simplify further, there's a hand up. Let me check, or a message. Good. So when I simplify this one further, I'll end up with 40 over 60. Remember how we multiply the fraction? The numerator multiply separately, denominator multiply separately. So this one will be 40 revolution. And then he denominator, this one the same as over 1. This one will be 60 seconds. 60 seconds. This one will reduce further to 2 over 3. 2 over 3. Now it will be revolution per second, and revolution per second is the same as hertz, which is our frequency. Then from there is when I allocate to angular velocity. Angular velocity, I say that it is denoted by omega. Don't confuse with angular velocity with the linear velocity as v. So the angular velocity omega is equal to 2 pi f. 2 pi f. That's how we get the angular velocity. And this one become 2 when I multiply pi, which is 22 over 7, that's constant, 22 over 7. Then multiply pi frequency, which we got it as 2 over 3 hertz. 2 over 3 hertz, like this. 2 over 3 hertz. Yes. When you substitute in your calculator, what will you get? 2 times 22 over 7 times 2 over 3 hertz. Napata nini?
4.190.
4.190. Then kindly don't do premature estimation. They normally say that you give your answer at least. So at least does not fix you to give 4 significant figures. At least should be that value and above. I encourage you to give above. So it will be 4.19.
04 05.
Imeishia hapo.
No, it's 4.190476.
76 like this.
76 like this.
Yes.
Good. SI in it.
Good.
SI in it. What is the S sign of
Meters
What is the
per
S sign of
second squared.
angular velocity?
angular velocity?
Oh, meters per. Oh, rads per second.
Rad per second. So
Rad
this
per
one will be rad, then per second. Like this. Let me align it. Good. This is the answer that I expected from the student. And I want to encourage that let us avoid premature rounding off. Premature rounding off. Premature rounding off. Give your answer in at least. At least means that value and above. So you aim higher. The higher the number of decimal, the higher the accuracy level is. And if possible, if your calculator can convert that answer into fractions, especially the simplified one, so that if it's improper, you make it a mixed fraction. That one will be more accurate compared to this decimal answer, unless the decimal is exact. Then the second question, that question, a wheel has a radius of 0.4. This was 0.4. 0.4. And makes 16 revolutions per second. Determines its centripetal acceleration. I noted that later that I have not discussed something on the centripetal acceleration. But again, this whole day work is only revision, something that you have already done in your classes. So you are just to apply what you did in your classes. So what is the formula of getting the centripetal acceleration, which is denoted by A? How do we get the centripetal acceleration? Kindly, Serena.
Radius times angular velocity squared.
Very good. Very good. So centripetal acceleration is equal to the R then omega square. R then omega square. Like that. Let me write the omega, the correct omega. Here, this one. So what I'm missing there now is our omega. But our omega is equal to 2 pi f, where we have the frequency. You apply 2 pi f, like this. Now, if we could have been not having that frequency, we could have applied angular displacement divided by time. Angular displacement divided by time, like that. So, because we have revolution per second, automatically this revolution per second gives us the frequency. Inatupea the frequency. So, when I substitute, clearly I have 2 multiply pi. Pi is constant, which is 22 over 7. 22 over 7. 22 over 7. This is our pi, the symbol pi. Then times frequency. This one is per second. Ingekuwa per minute, we could have done as we did before here to convert those minutes into second. So this one just multiply by 16. Like that. You get what? Kariuki, if you have closer, you have a calculator near you, what do you indicate? Moses? Serena, save us so that we spare time. Save time.
100.5714.
100 point
5714.
571 like this.
And that is our omega. It's not our acceleration, angular acceleration, our centripetal acceleration. So my A will be equal to the radius, which is already in meters. You should reduce the radius in meters. Then I multiply by our angular velocity, which is here, this one, like this. Unapata nini?
$40.2285.
228
5.
5.
Assign it
Meters per second squared.
Very good.
Very good. Meters per second square.
But we didn't square the angular velocity.
Oh, we didn't square this one. It's true.
It is true. I've noted that. When you square, you'll get what?
$4,045.8425.
Point
8425.
like that.
Very good. This one. This one. So if you want to get the centripetal acceleration, it is r omega squared. R omega squared, like that. So you need to get the omega, which is our angular velocity. Then from there is when now you'll use it to substitute in that formula of centripetal acceleration to get the centripetal acceleration, like this. Next, I will rotate at 45 revolutions per second. What is at 45 revolutions per minute? What is the angular velocity in rad per second? Kindly do on your side and then give me the answer, so that after getting the answer, you will direct me how you did it as I typeset on my side. Serena, do it, then you give me the answer. Yes, Moses?
The answer is 4.714 rad per second.
Very good. Very good, very good. Direct me how you did it.
I first found frequency, 40,
Frequency, which is equal to
45 over 60.
45 over 60. 45 over 60 hertz. When you simplify, the answer will be, when you simplify 45 over 60, Kariuki?
9 over
9
12, and then you get 3 over 4.
9 over 12.
Yeah.
It's 3 over 4. 3 over 4. 3 over 4. 3 over 4. This one is 3 over 4. This one is hertz. Yes, then from there, you go to?
I use the formula for angular velocity 2 pi f.
F. Good, which is equal to
2
2
times 22 over 7 times 3 over
times
4.
times 22 over 7, and then multiply by 3 over 4. 3 over 4. So finally you get?
I get 4.7143.
Like this.
Yes.
Then this one is rad per second. Rad per second. This one is rad. And then this one is second. Very good. Serena, do you call the same answer?
Yes.
Good. Very good. Very good. So that's how you are to work out that question that we did in our previous exam on Friday. Good. We continue. A body moving with uniform angular velocity found to have covered an angular distance of 1/7 radians in t seconds. 13 seconds later, it is found to have covered a total angular distance of 300 radians. Determine t. This one, how did you work it out? Let us do it, then you direct me how you worked it out. Do it on your side, then you direct me how you worked it out. Yes, are we through? Are we through? Moses?
No.
Serena? Serena?
Yes.
Are we through?
Are we through?
Yes.
Good. What are you getting? Yes?
17.
17. Exactly 17.
Yes.
Very good. Moses?
I've not been able to finish the question.
Okay. So we can work on it together, we see. So a body moving with uniform angular velocity is found to have covered an angular distance with the same as angular displacement of 1/7 second in t second. 13 seconds later, 13 seconds later, it is found to have covered a total angular distance of 300 radian. So my question is that, what is the distance covered in 13 seconds? What will be the distance covered in 13 seconds? Moses?
Right.
What will be the distance covered in 13 seconds?
$300.
Let me check. Listen, very good. Listen. 13 seconds later, it is found to have covered a total angular distance of 300 radian. A total of angular distance of 300 radian. Yes, now my question is that, what is the distance or angular distance covered in 13 seconds? Let us read the question. A body moving with angular velocity found to have covered an angular distance of 170 radian in t second. In t second, it has already covered 170 radian. 13 seconds later, it is found to have covered a total angular distance of 300 radian. Now my question is that, what is angular distance covered in 13 seconds? Serena?
130.
How
How did you quote 130?
I did 300 minus 170.
Brilliant. Very good. Very good. Very good. It is 13 seconds later, it covered a total. A total is by summing. And earlier, in T second, it had already covered 170. So mean that the later 13 seconds, it will have covered an angular distance of 300 minus 170. You get the answer as 130 radian, like this, radian. Then from that, we can get now angular velocity for 13 seconds. 13 seconds. The angular velocity is given by the angular velocity. This one is given by angular displacement, angular distance or displacement divided by the time taken, like this. And this one now will be, it will be the angular distance and the time available is 130 and the time available is 13. So this one will give us 10 rad per second. Rad per second. Rad per second, like this. So because this one is a rate of change, meaning that as this one change, this other one is also changing. It means that now it can be a uniform motion. So at each and every instant, that rate of change will be the same. So 13 seconds is equal to 10. It is giving a rate of 10, like this one. Or I can just use this one. I have now the angular velocity. I have the angular velocity here. Now, we want to get I have the angular velocity as 10 rad per second. I have the angular displacement here. I want t. Still from this, our angular, we got it as 10 rad per second, this one. 10 rad per second is equal to our angular displacement is, or angular distance, now it is now 170, and the time there is our time t, the one that we are lucky, and this one is in rad, like this. So when I cross multiply, I'll have the 10t, this one. I'll have this one. The 10t is equal to 170 rad, like this. Now, if I want to remain there with t alone, t as the sum of the formula, I need to remove there the 10 rad per second, so that I have there 170 rad, then divide by 10 rad per second. Clearly, this rad will cancel with that other rad. This rad will cancel with this rad. This other rad, like this. So this one will become 17 seconds. Better just write the whole 17 seconds, because when you write 17s, as with our handwritten, it will appear as 175. So maybe when you typeset like what I've done here, when I write 17S, it will be seen clearly. But on your side, when you write 17S, it will appear as if you have written 175. So instead of that, just write 17 seconds to avoid touting during the marking. So that is how I wanted that question to be worked out, like that. That is how I wanted student to work out that question, like that. We go to number 6. A marked point on a rim, of a wheel has a linear velocity. This one's linear velocity. Then we can do this. If the rim has a radius of this one, calculate the angular velocity of the rim. Remember that the relationship between the angular velocity and linear velocity is that linear velocity v is equal to r omega, this one. So clearly from this one, I just say that our omega is equal to, when I make omega the subject formula, I'll have v over r. Now with substitution, I'll have our v, which is linear velocity, 11.2, and should be meter per second, because some examiner can decide to give you in kilometer per hour. So divide by 0.8, like this, 0.8. Tunapata nini? Yes, Moses?
14.
40.
14.
14. That's angular velocity, that is rad per second. Rad per second. Next, they ask us to get what's called the centripetal acceleration. Centripetal acceleration, we say that A is equal to r omega squared. That is how we get the centripetal acceleration. So A is equal to the r then omega squared. Like this. So now I substitute. Our r from that question, they have already given us as 0.8. Then I multiply by omega, we got it as 14, but it is 14 squared. So I multiply by 14 2 times. You get what, Serena? Serena has left. Serena, yes, you get what? Our centripetal acceleration is equal to r omega squared. So when I substitute, I'll have 0.8 multiplied by 14 multiplied by 14. Moses?
156.8.
156.8. This one will be meters per second square. Meters per second. per second square. This one should be s square per second square, like this. Second last question. Second last question. A turntable of record player makes 33 revolutions per minute. These things of per minute we should note it. Per minute, automatically that is where we'll have the frequency. But if it is per minute, you convert those minutes equal divided by, because per is the same as divided by. So it will be over 60. If it is per hour, it will be over 3,600. So what is the linear velocity? So we just start here. How do we get the linear velocity? So linear velocity V is equal to the R omega. But from that question, we don't have the omega. So V can be written as R multiplied by, instead of omega, where we have the frequency is given by 2 pi f, like this. Now I can substitute, where my radius is 0.12. And you make sure that the radius is in meters. If one examiner can decide to give you the centimeters, convert into meters. Then multiply by 2, multiply by pi is 22/7. Then multiply by frequency. Our frequency f, it will be 33/60. 33/60. I'm divided by 6 because of these things of per minute. So clearly from that, napata nini? Serena?
Zero point 0.03771.
0 point? Serena, come up again. Serena, come up.
0.03771.
771. Is it exact? You may kata mapema sana. It is advisable you just even copy the whole answer in your calculator screen. 0.0377 alafu? You are breaking?
1485.
1?
4285.
4285.
428.
Is it 5? Let me check the chat box. Good. Moses? Serena is breaking. I think she has a problem in the network. Moses, I get
0.37714.
Hapa hakuna zero hii. Hii zero
Yes.
haiko hapa. Give me the complete answer on your screen calculator. 0.3771428.
571.
571. Very good. This one is linear velocity. It will be meters per second. Meters per second. So student, I want to advise you that don't fix yourself in rounding off early. Especially this where you can think that you have rounded off to 4 significant figure, kumbe you have rounded off to 4 decimal places. Hiyo kitu huwa inasumbua sana. Especially where the zero comes after the values before the first digit are all zeros and it has a decimal. You can think that you have rounded off to 4 significant figures, only that you have written in 1 decimal place or 4 decimal places, but not significant figures. So my advice is that copy the whole answer on your screen, be whether mathematics or physics or any other subject, unless the equation instruct you that give your answer to these significant figures, give your answer to these decimal places as the accuracy level in mathematics. But where there's no accuracy level stated, I want to re-advise you again and again. Never fix yourself. Never fix yourself by rounding off your answer prematurely. In mathematics, we'll deduct you a premature estimation or a premature rounding off. It is called the PE mark will be deducted. You will lost an accuracy mark because of PE. The last question. A fanfare ride of diameter, that's the bit of mathematics. Even if they put there what vocabulary is, we just take where we have the numbers. We don't consider the vocabulary. Because some of us, we have never seen a fanfare. But I'm seeing there 12 diameter meter. I know diameter, it comes from a circle. Makes a 0.5 revolution per second. That is a frequency. So you don't struggle taking what is a fanfare. What is the formula of getting a fanfare? No. That is their own language. My interest will be on those numbers. We have 12 and 0.5. And 12, they are saying that it's a diameter. 0.5, it is a frequency. So automatically from that, that is something that I know. So angular velocity. Another thing that we have already covered, how to get the angular velocity. So the formula of getting the angular velocity, we had already discussed over the same as angular velocity is equal to 2 pi f. 2 pi f. That's how we get the angular velocity, which is 2 multiply pi. Pi is constant, 22/7. Then multiply pi frequency. This one is in per second, so just use the way it is. But if it could be in per meter, we could have divided by 60. So we just multiply by 0.5. Tunapata nini? Serena? Moses?
3.14287.
Nipeleke polepole. 3.14287. 857. Very good. Angular velocity. What is the sign of angular velocity? Moses?
Rads per second.
Rad per second. Very good. Rad per second. Good, like this. Rad per second. Lastly, the last part is asking us to get the linear velocity. What is the formula of getting the linear velocity? Linear velocity v is equal to Moses?
R omega.
V is equal to R omega. Very good. R omega. Like that. Then from that, I just substitute our radius. Instead of radius, they gave us the diameter. And radius from diameter is diameter divided by 2, which is 12 divided by 2. Then I multiply by our omega. We got it on part A as this one. What will be the final answer? Moses?
18.857142.
Then that is the linear velocity. It will be meters per second. Meters per second. Good. So you can see how I've tried to organize my work. That is how a student is expected, at least, to organize your work. This is how you are supposed to organize your work. At least the examiner can see how you organize your work very well. Like this. I want this to be 2 pages. Let me see. Good. So this is how you are supposed to work out those questions. I want to call upon students to maybe identify for me where they got a challenge, so that when we meet in our next lesson, we see where we can polish. So which question that you saw that maybe it could be having a challenge that made maybe not to score 20 out of 20 for those one who didn't score 20 out of 20? Any question with a challenge? Let me start by Moses. Was there any question that you saw a challenge?
No.
No. You scored 20 out of 20? Did you? Oh, okay, good. Serena, any question that you put a challenge in? It was which question?
It was the part of the question where they had revolutions per minute.
Okay. In conversion. Good. But at least now, from now, you can tackle that question well.
Yes.
Very good. Very good. So that marks the end of our today's lesson. Just located it for revising the paper we did on Friday. So from tomorrow, we have to go back on that topic. I want to try my best so that by Friday, I will have cleared that content of circular motion. So please, in case there's a question asked before we end our session as we wait for mathematics lessons. Any question from any student? Moses?
No.
No. Serena?
No.
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 So I just want to stop there. The lesson has been very interactive. Thank you all for your attendance. Good day.